I'm Associate Professor at Princess Sumaya University for Technology. Today, I will present my paper utilizing linear regression and random forest models for money laundering identification. The roadmap for today is abstract, introduction, related work, methodology, result, and at the end, the conclusion. So in this paper, we investigate the effectiveness of traditional machine learning technique, namely linear regression and random forest, in enhancing the detection of money laundering activity with financial system. As money laundering schema evolve in complexity, traditional rule-based method struggle with high false favorite rates and a lack of adaptable, promoting the need for more sophisticated analytical approach, in contrast to the complexity of the deep learning model. The study explores the potential of these more accessible machine learning methods in identifying and analyzing suspicious transaction patterns. We apply linear regression and random forest model to transaction data to detect anomalous activities that could indicate money laundering. Our research through compare these models based on the key performance matrices such as accuracy, precision, and recall. The findings suggest that while less complexity than deep learning framework, linear regression, and random forest model offer sustainable benefits. They provide more streamlined, interpretability, and efficiency alternative to conventional rule-based system in the context of money laundering detection. The study contributes to the ongoing discovery on the application of machine learning in financial crime detection, demonstrate the practical and effectiveness of these methods in critical areas of the financial security. Introduction. In the vast interactive tapestry of global finance, the sensitivity thread of money laundering waves and complexity pattern threatening the very fabric of economic stability and governance. Money laundering is the process of making illegal gain process appear legally. It's not just a financial crime, but also it's a critical issue that undermines of the integrity of financial institution and the border economic. The United Nations Global GDP monitoring $2 billion. This staging figure highlights the urgent need for effective detection and prevention mechanism. Detection money laundering is a challenge due to sophisticated of method that used to detect the volume of transaction proceeds by financial institution. Traditional approach such as rule-based system and thresholding setting are often employed to flag suspicious activities. However, these methods are increasingly providing inadequate according to the different references. They are often reactive rather than proactive, heavily reliant on unknown pattern or known pattern, and generate a high value of false positive, leading to an efficient and investigative footage. Moreover, a money lender continue refine their tactics. These traditional systems struggling to keep pace, lacking of adaptable and sophistications required to counter such as evolving threats. In this complexity landscape, the emergence of deep learning, subset of machine learning characteristics, by its ability to learn more from data, represent a beacon of hope. Through their advanced pattern recognition capability and adaptability, the deep learning algorithm offer a powerful rule and tools against deceptions of money laundering. But at the same time, it's kind of complicated. And according to our study, we refer to more than 30 references that talking about the different techniques used a deep learning and machine learning algorithm to define the problem of money laundering problem. In different related work, the work presented in 24 introduced a supervised machine learning model that classifies transactions into three categories: normal, transaction flagged, and illegal. Uniquely, the model focused on the study underscore the importance including all data, particularly unreported alerts, in the model of the training process to enhance detection capability. Leveraging a comprehensive data set from Norway, that research conduct time validity analysis, ensuring it finding practical applicability and relevance. In other references, such as reference in number 16 and 25, believes in the alarming prevalence of money laundering activity, especially in the context of Bitcoin transaction. The research illuminates the struggling of amount involved within estimate 800 billion to 2 trillion laundering annual and highlight the significant portion attributed to cryptocurrency. Recognition and adequate of existing prevent measures. The study advocated for deploying advanced technology such as deep and machine learning techniques to develop effective identification and prevention strategy. Employing the Bitcoin elliptic data set, the researcher evaluate an array of machine learning models, include deep learning model, random forest, key neighbor algorithm, and Navy bias. Among all of these algorithms, the F score is remarkable. Unfortunately, the complexity of the system is very high. Other references, such as reference number 26 and 27, they highlight the central focus is to enhance the precision of anti-money laundering system, AML, alert system through supervised machine learning techniques. These models introduce a triage model as a part of machine learning component. Moreover, research number 28 and 29 investigate the application of machine learning algorithms and identify the companies involved in money laundering, with a particular emphasis on the data pre-processing and classification methods. But unfortunately, most of these algorithms achieve a high percentage in accuracy and low percentage in precision. Our methodology. Our methodology consists of the following process. The first step is the data collection. Then we will apply data cleaning process to clean the data from ambiguity and unclear data. Then we apply some techniques for feature engineering. After that, we divide the data into testing and training data sets. And then we apply the model selection, which is linear regression and random forest. And according to the result, which depend on the accuracy, recall, F measure, and the precisions, to evaluate the performance of the evaluation. So, to make it more clear, we will explain each step of the following algorithm. In the first step, we apply data collection, which is the initial step of our methodology. Involve collecting transaction data from financial institutions such as bank. This data set includes attributes such as transaction amount, date, account type, and other relevant metadata. The primary challenge we have it is the sensitivity nature of the financial data, required strict compliance with the data privacy regulation. After that, we go to the data cleaning. In the data cleaning step, we will ensure the quality and reliability of machine learning model. This step includes handling missing data values, correcting errors, and remove the duplicating. We employ techniques such as imputation for missing data and anomaly detection method to identify and rectify inconsistency in the data set. Step number 3, which is the feature selection or feature engineering. According to our model, we will try to transform raw data into more suitable format. We extract meaningful feature from transaction data. Consider transaction frequency, amount pattern, and historical account behavior. The goal is to encapsulate behavior pattern that might be indicate suspicious activity. In step number 4, we apply the data balance step, where we balance the fruit and unfruit process by using what we call about smooth algorithm to overcome of the oversample methods, which is the synthetic minority oversampling technique. And we apply undersampling technique ensure that the model are not biased toward the majority classes. Linear regression and random forest is the step number 5, which is the model selection. And we will select one of them due to the efficiency and the clarity in the classification rule. Linear regression is straightforward, offers significant insight into how various feature correlation with the probability of transaction being fraudulent. Whereas the random forest is applied for complex feature and relations against overfitting. These characteristics make random forest particularly valuable for analyzing diverse and interact data without losing prediction accuracy. Those ensure robustness in detecting fraudulent activity. Model training and evaluation is the step number 6. We will divide the data into testing and training, and based on this, we will find out the performance evaluation, and the model are evaluating based on the matrices relevant to anomaly detection of tasks, including accuracy, recall, precisions, and F1 measure. In these two figures, we find out the action according to the data. So in the figure on the left-hand side, we explain number of fraud and non-fraud transactions. And this data set is balanced data set, which is represent 1,000 of transaction is not fraud, and 1,000 of transaction is a fraud. In the right-hand side, we represent the heat map of correlation matrices, which consists of the relation between the fraud and non-fraud. And this heat map can be represented by using the Pearson correlation relationship between matrices and the class part. At the end, we have the conclusion, and the conclusion is show off the performance of our system. And we classify the fraud and the fraud in the class diagram, and that class consists of 0 and 1 results. And in this paper has presented a comprehensive analysis of the application of linear regression and random forest model in identifying money laundering activities through methodological data pre-processing, feature selection, and model training. Me and my partner, Dr. Anas, have demonstrated that machine learning can significantly enhance the detection of a fraudulent transaction in a large data set. Our results indicate the random forest model outperform linear regression in terms of accuracy, precision, and F1 score, suggesting that the former is better suited for this classification tasks. The robust nature of random forest is handling the nonlinear and complex pattern typically associated with the money laundering activity account for its superior performance. Furthermore, the recall matrices highlight the sensitivity of the logistic regression model, underscoring its potential utility in scenarios where capturing as many fraudulent transactions as possible is critical, even at the expenses of increasing false positive. This research significantly contributes to the ongoing discourse of the application machine learning in financial crime detection. It demonstrates the practical and effectiveness of linear regression and random forest model to potent model tools for enhanced detection capability of financial system against money laundering activity, thus providing a valuable resources for financial institutions aiming to bolster their defense against such sophisticated crime. At the end of this presentation, I would like to thank you, and please, if you have any questions, you can go and read the paper, or you can send an email for me to answer you. Again, thank you so much. Have a nice one.